Okay, let's get moving now with graphing linear inequalities. All right, so this kind of ties into what we were doing with the first part of this lesson, where we just worked on graphing linear equations. Now, with a linear inequality, you're going to do this. You're going to start out the same way. Obviously, we have a couple extra things to consider with inequalities that we don't with equations, but we'll talk about those. And then when we graph, we're going to have something that looks a little different. So let's take a look at this first sheet here. So it says linear inequality resembles a linear equation, but with an inequality symbol instead of an equal symbol, right? And we're familiar with these, right? For example, y is greater than negative 3x minus 2 is a linear inequality, and y equals negative 3x minus 2 is the related linear equation. And the reason they call them related is because they make basically the same line on the graph. So if you remember how to graph this, you have the hardest part of graphing this completed already. Okay, and then it says you graph this as a shaded region. So because it's an inequality, guys, there's not one value, or there's not just a set of values on a line. It's like there's a set of values like on one side of the line that are going to all work, and the other side of the line will have values that don't work for that inequality. All right, and so we shade the region that makes the inequality true, right? So the shaded region is this side is where the inequality is true, and this side is where the inequality is false. In other words, if you put a coordinate pair from this side into this inequality, right, it will not work. So for example, if we grab, let's say we take the point -4 and -1, and I put it in here, right, you would have -1 is greater than -3 times -4 is 12 minus 2. So this side becomes 10, right? This becomes 10. So is -1 greater than 10? No way, right? And then the other thing is the boundary, right, is the line. And you'll notice on this one it's dashed. So the rule for that is that if you have, I'm going to switch over to black here. If you have this or this, you are going to have a dashed line. All right, so you're going to have a dashed line because it does not include the points on the line. All right, does not include the points on the line. And so if this should remind you, God, it sounds stupid right now. This should remind you of when you were graphing them like this on a number line, right? We had either the open circle or the closed circle, right? The open one was, it didn't include them, and then the closed one, it did include that point, right? So it's the same concept, except it's a line. So now if we have this or this, you're going to have a solid line, and that means it includes the points on the line. All right, and so that's kind of the general idea, and then I will show you how to figure out how to shade this. So let's do an example. All right, so we have this right here. So the very first thing I want you guys to do, at least for right now, is I want you to rewrite, we'll call it rewrite in slope-intercept form. So slope-intercept form. Okay, so we have x plus 4y is greater than 2. So slope-intercept form, let's leave the y here. Let's move the x over. So we're going to go minus x, and you get 4y is greater than 2 minus x. Next step is I want it to look like slope-intercept form is y equals mx plus b, right? And so I have a 4 here that we got to get rid of. So let's divide by positive 4, and we're going to divide everything by positive 4. Okay, so that's going to give me y is greater than 1/2, because 2 divided by 4 is 1/2, minus x over 4. Now, the thing to remember is when you don't have a number up top and you're talking about slope, people get nervous, but x is technically up top, right? And if there's no coefficient on a variable, it's always 1. So we can rewrite this as 1/2 minus 1/4 x, right? You can just pull the fraction away from the variable, put the variable kind of in the middle. It does belong on top, but if you put it in the middle, that's kind of implied. And then let's just rewrite this and just take this whole term and move it in front. So we're going to go -1 for x plus 1/2. And so now I know my slope, and now I know my intercept, right? So I'm going to go to 1/2, and I'm going to put a point. And now this is going to be a little tricky because it's 1/2, right? But we can still do it. So what this says is we're going to go down 1 and then over 4. And so when you go down 1, remember you're in the half, right? So we're going to go down 1, so that puts me at the -1/2, right? And then over 4 is going to put me right here, so we're going to have a point right here, okay? And then when you draw your line, you should be able to make that work, right? And so I'm going to, I don't know if I can draw dashed lines on here. So I'm going to kind of pretend to draw a line here. Let's see if I can move it maybe a little bit. So, well, let me move it. Turn it a little. Nah, it's not. All right, so regroup. Let's get rid of this. All right, and then we will do it like this. We'll just go boom, and I'm going to leave it dashed because it does not include the point, right? It's not greater or equal to, right? So it's dashed. So now what you do is you find a point that is not in, that's in one of the regions, that's clearly in one of the regions, and you test it and you see if it's true or not. So let's take, let's take the point 2, 2. All right, so let's take this point right here. So we call this our test point. All right, and if we put the test point into this original inequality and it's true, then we're going to shade the side that the test point is on. If we put it in and it's false, we're going to shade the other side. All right, so let's give ourselves a little room here. So we're going to go 2 for x plus 4 times 2 for y is greater than 2. And so you have 2 plus 8 is greater than 2. Is 10 greater than 2? Yep. So what you're going to do then is you're going to shade this whole side. And Alex has this nice feature where it just shades it. Like you just click on it and it shades everything for you. So you shade the side that has points that work, right? And so if you put a test point in and it works, then you're shading that side. If you put a test point in and it fails, it's not true, then you would shade the other side. Because one of the sides has to be right. So that's kind of how these work, guys. So I'll pause the video here in the interest of keeping it from being stupidly long. And the next one, we'll do another one.